Hello Internet. Today we're going to be taking a look at a relatively older project of mine. This is Unity-STL, and the idea of it is that it can take a mesh from Unity and export it to the STL file format, and then you could import that file into a 3D printer software and use that to actually print a part of or most of a Unity scene inside of your 3D printer. I have some examples in this project. And so like I did like a little minifig. The printing quality was terrible because I was just demoing this. But like you can take these meshes from Unity and do that. There's a bunch of videos on it. The reason we're coming back to this is because it doesn't work. And by that, I mean, it works some of the time. It depends on where you live. And so this is one of those weird internationalization problems that we happen to be running into because I live in the United States. And so when we're doing number formatting, we use a period for our decimal places. That isn't the case everywhere. Some places use commas. And so when I'm using a standard string exporter to format a number and print it out, it's going to use the local setting for that. And so if you're living in a country that uses commas, it's going to put commas in your numbers. And so the problem that we're running into is we get files that look like this. And this took me a bit to figure out what was going on. But the problem is this is for a cube, so it should be 0.5 and just kind of have all of those sides. This is defining triangles inside of that shape. And so the problem here is we have 0.5 and it should be 0.5. And because it's not 0.5, everything breaks. So we need to come up with some way to fix this. And so I figured we'll just record the whole thing and hopefully kind of turn that into something that's kind of helpful. I guess this is also a good lesson on internationalization. You might see that written as I18N because internationalization is a long word to type and just people don't want to do it. The 18 is for the 18 characters between the I and the N in internationalization. Anyway, we're gonna just pull this project down. This has been out on GitHub for 3 years now, and so you could always go and get this. A lot of my projects are out on the World of Zero GitHub. I'll put a link to that in the description. There's lots of shaders and things out there. But anyway, there's a bunch of files here that are doing different things, and it's been 3 years. I don't really remember what's going on, but what we need to do is make it so that when we're writing to this file, that we are using a specific format and not just whatever the local format is. And so that's what we're hoping to fix. So I'm going to pull this whole thing down and we should use it. There are a few other features if I remember correctly. And so we might get more stuff, but this should all work. I don't think there's anything that would have been a breaking change between now or between then, which I think this was Unity like 5 or something we were using, and Unity 2019, which is what I'm going to be using. So first thing we need to do is just create a new Unity project. I'm going to use that one. And we'll just call this our STL. Sure. We're not going to use any fancy render pipelines. It shouldn't matter what you choose. This is specifically working off of mesh data only. And so there isn't anything special in there. And this STL format doesn't really have that much going on in it. It's defining what basically facets. And so if you're familiar with like basic, I guess it's kind of that kind of syntax. So this is one facet. And the idea of that is it's a triangle in your shape. And so Unity already provides those triangles. So we're literally just reading those in and figuring out what the normal for that triangle is. And then adding all 3 vertices that are part of that triangle and then just creating a list of them. So that's all this should be doing. And so that's sort of how the file format ends up working. When this is working, we should be able to pull our cube. I guess we'll work with a cube. That probably is the easiest. Just because you get these nice even numbers that you can actually tell what they mean. We'll probably be working with this and then just pull that into like 3D Builder. 3D Builder is just a really basic 3D CAD. I don't know if it's really CAD software, but you can do basic 3D manipulations and 3D printing from it. Unity is over here. There we go. So this is our new project. There's nothing in it. And so what I need to do is clone that STL repo into this new STL project we have. So I already have a shell that is over there. So we are just going to go cd, we called it STL. And we just need to get into our assets folder. And then I'm just going to do a git clone of getting lost. There we go. Too many things open. We need to get the clone command for this. So just grab the URL and we're just going to plug that into git clone. This is going to clone that repo into the Unity-STL folder. So inside of our assets folder now, we should have this new Unity-STL folder right there. And hopefully no errors. Perfect, none. This is cool. I can ignore it. For whatever reason, creating new projects in this version of Unity throws package errors. I'm not entirely sure what's going on, but we're going to ignore it. There's documentation. This is intended as like a full Unity project. So there's another assets folder and then the Unity-STL, and it gets weird. Theoretically, we could have just cloned this directory into our project. I just grabbed the whole thing just because I could. And so this is what is going on, actually. I think we have some sort of fancy mesh preview editor. Yeah, this thing. So this is a custom editor that we made to kind of show these things off. So we should be able to grab our cube, and you'll see it actually just creates the spinning version of it in here. Again, there's another video on this. And so what will happen is we'll click this export STL thing. Access to the path C mesh.stl is denied. Okay, so I just can't write to my C directory. So that is fine. Let's see here. Mesh builder. How does this work? Editor, mesh preview editor. That's going to be where it is. So there's a mesh editor that's actually rendering that sample of whatever mesh you select in the Unity editor. It's going to take that and render it so you can actually see what you've selected. And then when you click the export STL thing, it's going to write it out for you. I forget how this all works, but the nice thing is we don't actually need to know how all of this works. I've covered that in other things, so we're not going to go through it. We don't really need to. Instead, we're going to focus more on fixing things. So export STL is going to write to our C directory right here. So instead, can I do a local path? So we could do path dot join. I think that's the function for it. And then we want to do working directory. I don't know exactly how to get this, so we're gonna guess a bit. I guess we'll just do this. This will be faster. Up get the working directory. So the working directory is wherever the program is originated from. I don't know if that, yeah, get current directory. I guess I knew that. It's just been a while. So directory get current directory. That should get the current directory, and then we're just going to pass in mesh STL. And then we're going to write out that STL file to that directory. The reason I'm doing this is hopefully we have more permissions here. The change isn't required for what I'm doing, but just writing things to the C drive isn't probably the best thing. And we'll just call this exported mesh.stl. Just because I'm re-looking at this code and doing a code review, and because I can. And so there we go. We should have this. You can see no game objects is selected, so we just select a cube. We have this export STL. We can change the zoom, I guess. Okay, it rotates really fast. Export. Path does not contain definition for join. Path.combine. Okay, I guess join is, I think, Java's thing, and Python, I think, does join as well. So one of the side effects of starting to learn all these different languages is you You start mixing them up. Anyway, we're going to click that export STL button and see absolutely nothing. I think that's what we want to see. Don't actually know. So we're going to do this. We have this STL.solution exported mesh. So we should be able to just drop this into 3D Builder. And there's our cube. That's what we want to see. The problem again is if you're in a country that does not support this, can I change that? I don't really want to mess with that actually. I was thinking we could just change our locality and get that to generate the failed thing. I think I'm going to skip that because we can force it instead. And that is probably going to be easier. So STL builder.build is what we want to use. That generates a text blob of whatever is in our STL thing. So we need to go into this STL builder thing. And this is literally the entire file is generated right here. It's just a string builder that's doing a bunch of stuff. We're using a string builder here because concatenating strings is going to cause multiple memory allocations. If you join two strings together, you just allocated 3 strings in memory because you did the first string, the second string, and then the combination of the two. With a string builder, you can kind of avoid some of that. So you stop generating all of these throwaway strings, especially if you're constantly appending new things like we're going to do here. So that's why we're using a string builder. And then we're not even using like any fancy symbols or anything to generate spaces where it's all done manually. Wow. Okay. Interesting. Okay. I guess it works. We aren't using any of the new formatting stuff either. I don't think that was available back then. But anyway, we're using toString. toString is the problem. We need to fix this. I can't fix it. Okay. Not that. So let's see. C# toString. I don't know if we can use toString or if we need to use something else. There is a way to provide localization to this. I just don't know exactly how to use toString because this is the first time I'm trying it. There is String.Format is probably what we want. Yeah, I think that's what we're going to want. So there is a culture info object that describes globalization stuff. So you can provide specific cultures to it. So if you've probably seen like EN-US for English United States, and a few other different combinations of those. I don't remember all of them. There's a lot. You can provide a specific one and it will use that. There's also a number format, if I'm remembering. Yeah. And I don't remember what this is for. Decimal places, something, culture info. I guess we could just generate our own culture. That might be what we want to do. So let's explore, because I honestly have never used this, so we're gonna figure it out. But in order to do that, we want to do something. Right now we're using String.Format to do all of this stuff. We want to swap those out. And so, not what I wanted. Equals get number format culture. Can I nope. Okay. My formatting for generating cultures is still not working. So, or for generating functions, not cultures. Public static. We could make this just a constant, I guess. That's what it's going to be. I'm going to make it a string though, just so we can change it if we need to. I don't think there's ever going to be a need for that, but we're going to do it anyway. Culture info. Get number format culture. And there we go. There is our fancy function. And so what we want to do here is create this. So culture info equals new, not new, culture info. I don't know how to use these. I think it's in the globalization namespace, if I'm remembering. So if we do culture info, whoa. Okay, IntelliSense is still broken. Great. System.globalization. And so they're using just culture info blah. I think we can do something else here, because all we need is the number format. We don't need to specify all this extra stuff, because this stores more information than just the number format. It's going to store things like what does the currency symbol look like and things like that. And we don't need any of that. So we'll see. All right, so system.globalization, we have our culture info dot create specific culture string. Can I create a new one? No. Okay. We'll just do this. New culture info of NUS. So this should be native, like English US. That should already fix it. I'm going to specify the number format explicitly, just to make it actually work. Digit substitution, I don't know what any of these mean. Currency, decimal separator. There. And so if we wanted to do this, that would generate our commas. I guess we can start there. That should actually generate a failed file, because we already demonstrated that what we're exporting works. So if I do this and then we get the failed file, we'll have a better indication that things are actually doing what we want. And then we just need to return this culture info. So we have this now, and I think it goes on the front of these formats as a format provider. I don't actually know much about this object. Yeah, so it's a format provider. And so it's going to tell String.Format how to do things. And so when we're formatting all of this stuff, it should just work. So we just need to do culture blah. And we'll just stick that everywhere. I think there's a easier way to do this too, in order to append all of this once and not have to constantly do it. Those are static strings, so there's no formatting going on. Culture. There we go. This is wrong. I thought it was a string format. It's not. So we're just going to remove that. And so this should hopefully format everything for us. So if we run through this, do this, and select our cube, if we click export, that's a other random error. We're going to ignore that one. And we get this exported STL. And so I guess the easiest way to see what happened is to open this in VS Code. And it looks just fine. Okay, great. That's not what we want. So let's delete it and export it again. And see if that made any difference. It did absolutely nothing. There it is. All right, cool. Open with code. Okay, so it's a good thing that we tested this, because it didn't work. And I'm not sure exactly why. Let's switch to a German code, because that should break it. German culture code. We're just gonna get lost for a bit. Hold on. Sure, whatever. Whoa, bye. Okay. Well, that site is bad. What the heck? Okay. Maybe Germany. That's not how you spell it. All right, there we go. Normally these are a lot easier to find. I'm not sure why I'm having so much trouble. I typically just type it and go. Supported culture codes. Sure. Sure, let's try that. So if we swap out that, we effectively are changing where we're located to Germany, and not where we're located so much as we are targeting it towards a German culture, I guess. And so we're trying to format things to respect that. And so hopefully we can break everything by doing this, deleting our mesh. I don't know. I'm just going to click that a bunch. And let's open it with code. All right. Now we have our commas. Perfect. So we broke everything. And so I guess it's working, but for whatever reason, setting the decimal separator didn't do anything unless that's not the right thing. Hold on. Maybe there's something else. Oh, currency decimal separator. Well, of course that's the wrong thing. One sec. Let's not do currency stuff. Let's do. Oh, this is all kinds of stuff. Percent. We don't want percent's number, decimal separator. All right. So we just swapped this out for number. Like that. And this should fix everything that we're doing right now. So if I run this again, run that. And I didn't delete this beforehand, but it worked. So now we have periods here. So this can actually be imported again. So that's fine. I should show you when this is using the commas, it breaks. So if we take our periods and search and replace them all with commas, there shouldn't be any other periods, so that should be fine. This doesn't work. Regardless of what thing you import them into, it should break. I lost that. So in this case, it just goes really small. I'm not sure entirely what's happening here, but there's nothing here. I'm pretty sure it's just like saying 00 is what you imported and whatever. So we'll just cancel that. That's fine. So yeah, well, sure, whatever. Don't save. We're going to fix this. So let's do NUS, go back to that, and we have our period again. And so this should all work. This isn't necessarily required, but it should be fine. Another option is to use the owner's culture info here. I am not doing that because if we have that, there are all of these different use cases. It's sort of like times, right? Where time seems like this relatively easy thing to understand, like in 60 minutes there will be an hour, except it doesn't always work like that. And so that all changes depending on where you live. Even in the same country, it can be different. Even in like the same relative location, it can be different just for random reasons. This could be the same thing. And so by being more explicit in what we're expecting, we can reduce the noise and the variability of what we're doing. And so that's sort of what we're doing here. In this case, we're targeting the format that this file format is expecting, that STL expects. We're not targeting like human consumption. And so that's sort of what I'm doing here, is trying to make it so that it works as best as I can with this. And so that should be all we needed to do. There isn't too much to this. So I've talked for a long time about writing 3 lines of code. But this is kind of a complicated subject, and this coming up kind of gave me an opportunity to kind of dive into it a little bit more. And I hadn't really worked with like number formats before. So now I have. Cool. So this should all work now. So we'll just do this just to double check. We can delete that, export it again. Maybe. I think you need to double click for whatever reason. The first time is to select the editor window, and the second time is to actually click the button. I'm not sure if that's something I did wrong or whatever. It's not something I'm going to fix now. So we're going to do that. But here is our cube. It's imported. It should be fine. So that's everything we needed. Just to inspect this, everything looks fine here as well. We're expecting the normals to be on vectors of like the lines, I guess, the axes of our 3 dimensions, and they are. We're also expecting all of these values of the triangle to be 0.5 and plus or negative. I'm not really double checking that they're correct. As long as our mesh draws right, it's fine. I don't think I cared about winding, mesh winding when I was doing this, but it should respect Unity's mesh winding, so it should also inherit that. Anyway, we're not going to go into that. This works, so that's cool. What we are going to do is submit the fix. We're gonna actually say we fixed this. So we're gonna do a good question. What am I going to do? Live share, STL builder. That's great. Whoa, that's a lot of stuff. First thing we're gonna do is create a new branch. We already started writing things, but that's fine. We're just going to do it anyway. So we're going to create a new branch, and we're going to call this fix, not that, number formatting. Sure. There's a number formatting branch that we just created. There's nothing in it. We just forked it from, or not forked it, we branched it off of master. And so now we have 2 branches. The master branch, which everybody sees on the repo, and then the number formatting, which is local to my machine. This is Git, so everything is sort of distributed. Just creating a branch, nobody else is going to see that unless they have access to your machine. So we just created the number formatting branch locally. We need to add our changes to it. So there's 2. There's the STL builder that looks like this. So we'll just click that plus, and that's going to stage the changes. We can also do that from the command line. So go into here. We're in our STL. Let's use this instead. So let's jump into STL something. What's it called? Unity-STL assets, whatever. And you can see I have a bunch of shell extensions to kind of add all sorts of nice formatting to my shell. So you can see it's detecting 15 additions, 1 modification, and no deletions. And we are currently differing from our head, everything the public changes, I guess, by 1 modification. That's what this squiggly line means. So these are the staged changes, and these are the undone, like changes I haven't acknowledged yet. So what we're going to do is we're just going to add this file as well. So this is exactly like clicking that plus in Visual Studio Code. We're just doing it 2 different ways. Doesn't match the spec. What? Oh, okay. So we're going to cheat a little bit and just, does this work? It does. Cool. So what I did is did 2 stars and then a slash and then the name of the file. I don't know where the file is. I know where the file is, but in this case, I don't know where the file is. I just know what it's named. And so what I'm doing is saying, find any file named that is in any of the children directories. And so it's just going to add any file named mesh preview editor.cs. And so that's what we did. You can use just 1 star to do that for the current directory, but by doing these double star, it should crawl the entire subdirectory. So this should update, and now we have those 2 changes there. We could also do this from the command line. It's just git commit -m to add a message to your commit message. But we're gonna just use this. I just figured I'd show that. Git is one of those things that makes a lot more sense once you actually use it on the terminal than visual tools, in my opinion. It's kind of one of those things that you need to understand how it actually is designed to work. And the terminal is sort of where it has its origins. And so it kind of just ties better into that. But here we're just going to give it a commit message. So we are going to type fix STL files using incorrect decimal separator. Cool. All that I don't commit my meta files. They're not needed. They're like extra metadata that Unity stores. You don't need this. It will regenerate this for you unless you have like other things that you're tying, like Unity specific modifications that you've made. You don't need to include this in your Git. And so I don't in this case. Sometimes I will, depending on what I'm doing, but this isn't one of those. So we should be good here. All those files we can just ignore. And then we're just going to commit this. And so that is committed. Again, only local. We haven't done anything. Like nobody else can see these changes. There isn't anything there. What I do want to do though is push this to the upstream branch. So in this case, there are, like I mentioned, Git is sort of a distributed system. There's a whole bunch of different servers doing everything. There's my computer, and then there's GitHub's computer. And so what we need to do is tell this to submit our changes, our local changes, to GitHub so that it actually knows what's going on. And so that's what pushing means. So we are going to push to GitHub's upstream. There's a fancy little button here called Publish Changes. And that is just going to sync everything. And so it's going to take this new branch that we created and push it up to wherever our upstream is. In this case, it's GitHub. It's just a standard Git thing, so any Git server would work. But we're just going to click that button. That is actually a lot easier to remember than the command line stuff. I forget that all the time. So we're not going to do that, especially with new branches. That gets a little confusing. So we did that. And so I should be able to just refresh this and we should see some changes. So there's no longer any staged changes. They're all gone. And that's it. We're done. So what I should be able to do now is go down to GitHub, grab this, and see there's a new number formatting thing. So GitHub found my new branch and is like, oh, cool. And let's just compare it and create a pull request. And that is pretty much it. I have an issue for this. So we are going to do fixes number 1. I think there's only one issue. Did I even create the issue? Maybe not. Maybe I wrote it and never submitted it. Well, okay, sure. That's fine, I guess. Oops. But anyway, this is where we're going to create all of this extra stuff to actually submit this change. I'd point out what I'm doing here so far should be identical if you want to make these changes to any of my projects. What's going to happen is if I click this create pull request, it is going to send a message to the repo owner, me, that somebody has created a pull request. And then the way this works is I have to accept it. The only difference is you can't create branches for my projects. You would create a fork. You would create branches there. You'd make your modifications to your project or your fork of my project. And then you would push them back to me. That's how that would work. Anyway, we're just going to create this pull request. And so this part will be the exact same. You will see this create pull request. If there were tests or any integration, it would run those. I don't have any because this is just a really quick hack, more or less, to kind of tie Unity to 3D printing. So that's done. And so once I do this, I can just click merge, and that's it. I can also close it or comment on it if there's things that should be changed, or even leave comments on these specific files. So I can do things like that. I don't know what these say. But yeah, this is how that all works. So you can have discussions there. We're just going to merge this because it's good. So confirm. And there we go. That's that. I'm going to delete the branch because it doesn't need to exist anymore and it's just confusing. And so now that change should be available and it should be there for you to go and grab. So I will link this in the description, and hopefully this was helpful. It's kind of more of a like software management and like weird problems that can come up that you may not think of. I know this was not a consideration that I had when I was writing this. It just sort of happened. Somebody came into the Discord and mentioned on an older video, hey, this isn't working. I'm getting really weird results. And then they sent me the file and I was like, oh, that's not right. So now we know. I guess that's something I should probably write tests for. I guess in a more serious context, that's what you would do for this. Is you would, when somebody comes to you and your stuff isn't working, you write a test for the stuff. If it's supposed to do what they're saying, you would write a test that produces the results that they're seeing, and then you would make that test succeed. I didn't do that because that's a lot of work. And at least at this point, I'm not ready to spend that much time on this. So there's everything there. Hopefully this is helpful, and yeah, hopefully it's interesting. If you want to check this project out, I thought it was really cool when I was making it. The 3D prints I did here are like super quick things that I just kind of tried. Like you can tell this isn't going to print very well. The top little spire thing isn't there because you can't really 3D print those. But they're just like really basic examples. And so if you want to take some model or some scene and compose something in Unity and use that to export to a 3D printer, this works. It should do that. There might be some changes, and if there are, then submit an issue or come and ping me in Discord or something. There's a link to that in the description as well. But anyway, I'll end it here. So thanks for watching, and I hope to see you in the next video. So till then, see you, Internet.